Hello everyone, my name is Benjamin Danso and I'm from the West Africa Center for Crop Improvement in University of Ghana. This work is titled Validation and Utilization of SNP markers for Introgression of late leaf spot resistant genes in peanut. Late leaf spot disease is a very important disease in Ghana and West Africa in general because it can cause about 70% yield loss to peanut. Although there are chemical options for controlling late leaf spots, it is highly recommended that we use host plant resistance as that can offer a safe and efficient way to control late leaf spots. Molecular markers such as the Single Nucleotide Polymorphism markers are known to promote selection efficiency and genetic gain in breeding. 4 SNP markers have been already identified, but then they are yet to be validated in West Africa and in Ghana. The most popular variety of peanut in Ghana, which is known as Shitauchi, is susceptible to late leaf spots and it needs to be improved. So there were 2 objectives for this work. First was to validate the 4 SNP markers for usage in West Africa's environment. And then secondly, to introgress late leaf spot resistant genes from CS16, which is a resistant line, into the farmer preferred variety known as Shitauchi, using the marker-assisted backcrossing technique. So for the validation work, what we did was to first generate an F2 population, 150 of them, through a cross between the LSLS resistant CS16 and then the susceptible Shitauchi variety, as shown in plate 1. So small portions of cotyledon were sampled from each of the 150 F2Cs, and then they were genotyped with the 4 SNP markers at INTERTEK Laboratories. Information on the SNP markers are in table 1. The remaining portions of the F2Cs were planted in pots and inoculated with 20,000 conidia per ml suspension of Phaeoisariopsis personata, which is a causal agent of late leaf spot in peanuts. This work was done in a screen house. A 9-point rating scale was used to phenotypically screen the F2 plants, and then phenotypic results and genotypic results were all gathered. The SNP marker GKAMA02GL975 was not polymorphic, that is, it could not distinguish between resistant and susceptible parents. However, the other 3 markers were polymorphic as shown in table 2. SNP markers, the 3 SNP markers which were polymorphic also were used in a regression analysis, and it came out that they all had adjusted R-square values which were greater than 0.5 as shown in figure 2. And this indicates that there's a strong relationship between the validated markers and late leaf spot resistance in peanut. Hence, we were on good grounds to use the 3 validated markers to guide our second objective, which is the marker-assisted backcrossing program. So figure 1 shows the breeding scheme which was used. It started in February 2018 and we are still on it. The Shitauchi variety was used as the recurrence parent and was the female, and then the CS16 was used as the male, which is the donor. So the first cross of the parents generated an F1 population, which was backcross to Shitauchi again. So we generated, after selection, we generated a series of backcrosses until we got to backcross 3, and then we selfed. After selfing, we generated backcross 3 F2 population, and we've done a series of foreground and background selection, and we are now at a stage where we are doing agronomic evaluations with the hope that we'll soon release Shitauchi back to our farmers. So in conclusion, what we've done is to validate 3 out of 4 proposed SNP markers for late leaf spot resistance, and further use the 3 validated markers to assist foreground selection in our marker assisted breeding program. Thank you very much.